Hello everyone. In this video, we are going to explore a new feature of LuBan. It is called tiling. We open LuBan software and then open any STL. I have a head model. This is the STL. Then I'll go to Mesh, LuBan. The tiling method is here, set to tiling. You can set the model size and set a few control parameters. Tiling basically applies a photo onto the 3D model. The ideal photo to apply to is some sort of texture. And I have three examples here. The first example is a chessboard texture. The second example, this is like a knot, double knot texture. And we also have another one that looks like a knot pattern, a sewing pattern. We are going to try this on our model. When you see the model in the window, the texture is not applied yet. You have to click Select Image, select the chessboard pattern. The pattern is quite deep imprinted into the model. You can change how it looks. First, you can change the model size. If you increase the size, let's say to 90, and then the pattern is shallower, and the control to adjust the pattern directly is minimum raise and maximum raise. Changing the model size also changes it relatively. So I can set it to 20, then it is going to look very bumpy. Okay, so let's keep it 90. The first parameter I want to discuss is the direction. When we apply a 2D image to a 3D model, we actually have to segment the 3D model into several patches. So the direction tells the algorithm how to segment the model into patches. If we select Z, then a cutting line, you will see a cutting line horizontally that is perpendicular to the Z direction. If you select Y, then the cutting line is somewhere in the middle. It's in the Y direction, perpendicular to the Y direction. This is Y axis, and the cutting line is perpendicular to Y axis. And you can also set to X. That's the cutting line. The cutting line is quite obvious given the chessboard pattern. It will be less obvious if you select other types of pattern. Then the second parameter to discuss is minimum raise and maximum raise. Minimum raise corresponds to the black pixels. Here I set it to 0. So if the image has black pixels, it will have a 0 offset from its original surface. I can set it to a negative value, for example, negative 0.5. And in this case, the offset will be inward. The offset will be larger inward to the surface. I can also set maximum raise to a negative value, 0.1. As the difference between the two becomes smaller, the pattern will be shallower. Okay, so this is what it looks like with a minimum negative 0.5 and maximum negative 0.1. I'll set this to 0.6 and minimum to 0. So the model now looks like this. Angle. It is the angle to align the model with the image. If I change it slightly to 10 degree, you will see that the pattern is slightly rotated with respect to the position of the model. And that's how it works. You can also input a negative value if you want. Lastly, resolution. Sometimes the model that we upload is a low polygon model. If you use a low polygon model, let's see, if I use low polygon, maybe a cube. Let me include sphere. I have created a low polygon sphere, and then I'll go to mesh LuBan, set the resolution to a big value, K2. Okay. You will not see the image clearly because the resolution is very low. You can see the resolution by enabling the edge. This is a very low polygon model. Then if I reduce the resolution value, the size of the triangle will be reduced, and you sort of see a bit more details in the image. Reduce to 1. If I reduce the resolution to 1, you can see a lot more details. So the resolution value is useful when you input a low polygon model. With a high polygon model, the resolution will only take effect when it is at a very low value. So the resolution does not, given a high polygon value, and if you specify 10, the resolution does not reduce the polygon. So whatever the original polygon count that you input to LuBan, it will not reduce it. So if I reduce this to 0.4, we are going to see a finer model. And the middle artifacts is created by the cutting line. This is a low polygon value, so the triangles in between the cutting lines are messed up. Therefore, in most cases, you should still upload a relatively high polygon model. Okay, let's continue to play with the head model. Okay, when I change to a different image, you'll see different pattern. Looks ugly because the model size is relatively small and the maximum raise is a bit too big. If we change to 0.2, it looks better. And the seam is less obvious given this pattern. We can change the direction of the seam, and we can also set it to the Z direction. Okay. When you save the model to desktop, you are going to get several files. This is the 3D file, the project file, the original STL, and lastly, the tiling mesh. This is 3D Builder, and you can see the tiling mesh here. Okay. Last but not the least, the tiling method may not be applicable to certain types of mesh. For example, if you have a mesh that already has some kind of surface structure, then the tiling method is not applicable. You can still apply tiling to this mesh, but it won't give you very clear results. The tiling mesh is more applicable to mesh that has a smooth surface. For example, this one. If you apply tiling to this kind of mesh, you will get beautiful results. I will apply 3. Okay. we can increase the model size a bit more. Okay, this is the model that we get. And you can change the race of the pattern. I've just increased the difference between minimum and maximum, so the pattern is clearer. That is all for now. The method, because of the theme, I don't think the method is perfect. I will see if there is other opportunity to improve the underlying algorithm to deal with the theme in a better way. Thank you for your attention.